back to Bo Maths. Sorry for the long wait in the videos. I had a pretty busy week last week and then some technical difficulties which made it difficult for me to get a video out for you, but here we are, and I'm glad to see you. So today we are going to be practicing the last lecture video we had, which was on lowest common multiple, which was something that we could look at two numbers and see what are their multiples that are in common and what's the lowest one, and we saw how we could apply prime factorization in order to find that most efficiently. So today we're going to be practicing that concept, getting really used to the idea, and then I got some gnarly application videos, that's right, plural videos, just for you. So let's get into it. So here are the questions. Try them out for yourself, you know the deal, and we're going to start cracking along here. All right, so question 1. Calculate the following, and then I'm asking you to find the lowest common multiple of all these pairs. So let's start with the first one, the lowest common multiple of 12 and 26. So if you recall, the method we used to find the lowest common multiple was to first prime factorize these numbers. So 12 we can prime factorize as follows. And you must be an absolute master at prime factorization by now because we've been doing it just so darn much. All right, so there's our prime factorizations. Now, how did we find the lowest common multiple? What we did is we basically found all of the prime factors such that both of these are covered. So if we look at 12's prime factors, that means we need to have a 2, and a 3. And to cover 26's prime factors, we needed a 2 and a 13. But we already have a 2 covered, so now we just need to add in the 13. And now we've covered all their prime factors. 12's prime factors are covered here. And 26's prime factors are covered like so. And we see here that this number, since it has all of 12's prime factors and all of 26's prime factors, it has to be a multiple of both of them. And since this is the least amount of prime factors we could use to cover both of them, it has to be the lowest common multiple. All right, so we multiply this out. Let's see what we get. We're going to get, well, this part is 12 times 13. Well, if you remember what 12 times 12 is, that's 144. So we're just going to add on another 12 there, and we're going to get 156. All right, let's keep chugging along here. Lowest common multiple of 8 and 20. All right, so let's prime factorize these. And we look okay. What do we need? Well, we need the 3 2's for the 8. And then to get 20, we need 2 2's and a 5. Well, we already have 2 of the 2's, so let's just sauce in that extra 5 and we're good to go. We see we got all of 8's prime factors covered, and we have all of 20's prime factors covered. So this number is going to be the lowest common multiple of 8 and 20, and when we multiply it out, we're going to get 2 times 2 times 2, which is 8, times 5, or 40. So the lowest common multiple of 8 and 20 is going to be 40. All right, next on, we got 36 and 48. So, you know the drill, let's prime factorize these bad boys. All right, so if we write out 48's prime factorization, we're going to get 2 times 2 times 2 times 2 times 3, so that covers our 48. And to cover 36, we need 2 2's, we already have those, and we need 2 3's. We have 1 3, but we need to add in another one. So we've covered 36's prime factorization with these prime factors, and we've covered 48's prime factorization with these prime factors. So this number is going to be our lowest common multiple of 36 and 48, and when we multiply it out, what do we get? We are going to get, should be 144, I believe. All right, man, these aren't too bad, eh? Well, let's look at the lowest common multiple of 7 and 8. Alrighty, so these are some smaller ones, but that doesn't mean it's necessarily all in the bag. So 7 is a prime number, so that is its own prime factorization. Awesome. And 8, we actually already did that one up here, right? Its prime factorization is 2 times 2 times 2. So to combine all of these prime factors, we just simply need to do 2 times 2 times 2 for the 8 times the 7 for our 7. And so this is going to be 8 times 7, or 56. So the lowest common multiple of 7 and 8 is actually going to be 56. All right, so we're good to go. We just did number 1. And if you need any extra practice, just pick random pairs of numbers and find their lowest common multiple. You have no excuses to not get bonus practice here because, well, you can think of any two numbers and you know how to find their lowest common multiple. So go ahead and do that. Let's go on to number 2. All right, number 2 says, I have two different prime numbers. what is their lowest common multiple going to be? All right, so I have two different prime numbers. I don't know what they are, so I'm just going to write prime number 1 and prime number 2. Maybe prime number 1 is 7 and prime number 2 is 53. Who knows, right? But they are just two different prime numbers and different, so they do not equal each other. We want to know what their lowest common multiple is going to be. So how do we find lowest common multiple? Well, we find the prime factorization. But the thing is, what is the prime factorization of a prime number? Well, it's just the prime number itself. And when we find the lowest common multiple, we're taking the prime factorizations and we're multiplying them such that both of their prime factorizations are present. To do that, we're simply going to be taking the first prime number and multiplying it with the second prime number, because the first prime number is the first prime number's prime factorization, and the second prime number is the second prime number's prime factorization. So their lowest common multiple is going to have to be the prime numbers just times each other. So what this is saying is if I give you two different prime numbers, like 7 or 11, their lowest common multiple is always going to have to be the product of those two prime numbers. So in the case of 7 and 11, their lowest common multiple is 77. Another case would be maybe like 3 and 23. So in their case, their lowest common multiple is going to be 3 times 23, which is 69. So that is the lowest common multiple of 3 and 23. So we see here that we get a more general statement about prime numbers, maybe a little property of them, that if you would take two different prime numbers, their lowest common multiple is going to have to be their product. So let's move on to number 3. All right, give an example of two numbers that have the same greatest common factor as their lowest common multiple. All right, so we're doing a little practice with greatest common factor as well here. Well, if I took the number 8, for example, we know its prime factorization is 2 times 2 times 2. So if we could think of all the factors of 8, that's 1, 2, 4, and 8, right? These are the factors of 8. And if we think of the multiples of 8, that's going to be 8, 16, 24, and so on. What do we see here? The greatest common factor of 8 and some other number is going to have to be one of these numbers here. Because, well, in order to be a common factor, it needs to be a factor of 8 as well, so it's got to be among these numbers. And for the lowest common multiple of 8 and some other number, it's going to have to be among these numbers here, right? Because it has to be a multiple of 8. But the thing is, when are we getting a factor of 8 and a multiple of 8 being in common? It's only when that factor and multiple is actually going to be 8 itself. That is the only time that we can get a factor and a multiple of 8 being the same number, which means that for the greatest common factor and the lowest common multiple to be the same thing, we need to basically pair 8 with itself, because the greatest common factor of 8 and 8, well, that's going to be 8, and the lowest common multiple of 8 with 8 is also going to be 8. So basically, the only two numbers that will give us the same greatest common factor as well as the lowest common multiple is if those two numbers are actually the same as each other. Could be 8, could be 29, could be 3,000, right? So I hope that one made sense, and let's move on to number 4. All right, on to number 4 here. If I sound a little bit different, that's because I'm recording this second half of the video at a later time. I originally recorded it all at once, but then the second half kind of got screwed up, so we're gonna go back at it again now. That's all right. So can the lowest common multiple of two different numbers ever be prime? Okay, so how is the lowest common multiple produced? It's produced by basically taking the prime factors of these two different numbers and then multiplying them together, right? So for example, the lowest common multiple of 14 and 16, what we would do is we take their prime factors, which you can verify that those are the prime factors, and then we just go ahead and make sure that they're all covered, right? But the thing is, how are we producing this lowest common multiple? We're producing it by multiplying a bunch of stuff together, right? And if it's two different numbers, we're going to be having to multiply their prime factors together. So this number should pretty much always be composite. And that is true pretty much in every case, except for one. If I ask you what the lowest common multiple of 1 and 7 is, for example, well, we can't really look at the prime factorization of 1 to solve this, but let's just recall what the lowest common multiple is where we take the multiples of these numbers, right? So 1 is 1, 2, 3, 4, 5, 6, 7, and so on, right? And the multiples of 7 are 7, 14, 21, 28, and so on. And we see when is their first common multiple. And so with 1 and 7, we get that the first common multiple is going to be 7. So we do actually have a special situation where the lowest common multiple of two different numbers will be prime, and that's going to occur when we do 1 with a prime number. But any other situation, whether or not the numbers are prime or not, we're basically going to be multiplying things that aren't 1, and we're going to be multiplying prime factors together, which is going to produce a composite number, because composite numbers are made up of things being multiplied that aren't 1 or itself. So almost never, but in a really special case where we're doing the lowest common multiple of 1 with a prime, then we do get a prime for the answer. All right, so let's go on to number 5 here. All right, so it says calculate the following. Now here we have the lowest common multiple of several numbers, right? Here we have 3, here we have 4, and then I also asked for the greatest common factor of several numbers because we haven't done a problem like that yet. But you're going to find that it's not actually very difficult to do these. So let's go ahead and do that. So the lowest common multiple of 8, 12, and 20. So I'm claiming that the method should be pretty much the same. So let's go ahead and find the prime factorizations of all of these. And I'm just going to write them out, and you can try them on your own to make sure that they're the same. But we've done a lot of prime factorizations, so I think you won't be benefiting much from me doing them for you anymore. So we have the prime factorizations of 8, 12, and 20. And what do? Well, we just write out all the prime factors such that we cover them, right? So we got 8's prime factors covered. Now 12, its 2's are covered, but we still need the 3. And for 20, its 2's are covered, but we still need the 5. So we see that 8's prime factorization is covered by this. 12's prime factorization is covered by this. And 20's prime factorization is covered by this lowest common multiple up here. So that means it's a multiple of all these numbers, and this is the smallest one we could do, so it's the lowest common multiple. So now we just have to go ahead and multiply this out. So we'll have 2 times 2 times 3 is 12, times 2 times 5, so that's times 10, so that is going to be 120. You can check me on that, but it should be 120. So that is the answer to this one. Let's go on to the next one. Lowest common multiple of 10, 25, 14, and 21. So as you saw in the previous one, it's pretty much the same process, right? It's just there's some more numbers. So let's go ahead and find the prime factorizations of these. So we have 10 is 2 times 5, 25, that is 5 times 5, 14, that is 2 times 7, and 21, that is 3 times 7. So if we go ahead and write out all the factors up here, we're going to have 2 and 5, which will cover our 10. For the 25, we have one of our 5's present, but we need another one, so now this 5 and 5 cover this 25. For the 14, we need a 2 and a 7. We got the 2. We still need the 7. And for 21, we need a 3 and a 7. We have the 7, but we still need the 3. So now we see that, okay, 10's 2 times 5 is covered in this prime factorizations. 25's 5 times 5 is covered in this prime factorization. 14's 2 times 7 is covered in this prime factorization. And 21's 3 times 7 is covered in the prime factorization. So when we multiply these together to get what our lowest common multiple is, we are going to get 21 times 5 is 105 times 10 is 1050. So the lowest common multiple of all these numbers is going to be 1050. All right. And now let's go on to the greatest common factor. And again, the process is going to be the same as finding the greatest common factor for two numbers. It's just now we have three numbers. So we'll go ahead and get these prime factorizations. So we can get the prime factorization of 24, of 20, and of 36. And again, please check these for yourselves to make sure you agree with my prime factorizations here. And for the greatest common factor, we're not combining all of these anymore. We're finding all the commonalities, right? If you remember that from the previous videos on greatest common factor. So the commonalities in all of these are these two 2's. There's no other commonalities because there's not a third 2 in all of them, only here. There's a 3 here and a 3 here, but there's not a 3 in this one. And this one has a 5, but neither of those have a 5. So our greatest common factor is going to have to be just the 2 times 2 that we see common in all of these factorizations. So the greatest common factor of these numbers is going to be 4. And for extra practice with these, you can just pick random groups of numbers, more than 2 this time, so like 3 numbers, 4 numbers, 5, maybe get a little funky with it, go like 10 numbers if you want to be absolutely insane. And then find their lowest common multiple and their greatest common factor. The process is the same, it's just up to you with how many numbers you want to go with. Well, I hope you found this video useful. I think it was really interesting. We got a lot of cool different problems done here, and let me know what you thought of them, and if you maybe struggled with them, feel free to ask some questions. In the next several videos, we're going to be getting into some really spicy applications of lowest common multiple, and I'm really excited to show those for you. So until then, you have a great day, you stay groovy, and I'm going to see you in that next video.